All right, so we've looked at operations of rational numbers. Now let's talk real quick about the order of operations. Let's say I had 6 minus 2 times 3 squared is 1 over 2 squared plus 1. Okay, so order of operations, I'm going to use this as an example here. So we have is parentheses, how this is usually described, parentheses, then we have exponents, and then add, oops, not add, what am I doing? I'm getting ahead of myself, sorry. Let's try that again. Multiply or divide left to right, and add or subtract left to right. So when we say parentheses, that's what we really should be saying is groups. Parentheses is the most obvious way of grouping them, but you can also use things like brackets, braces. If you want, the top of a fraction is a group, the bottom of a fraction is a group. We're going to talk about absolute values a little bit. So that's a group inside of a root. That's a group. So anything, any kind of group of numbers. So here we have 6 minus 2 times 3 squared plus 1 over. So even though it's not written there, this top part is a group and this bottom part is a group. So we need to do those two before we do anything else. So this is going to be 6 minus 2 times. Now when I go up here and I want to do each of these groups, then I'm going to continue on with my thing here. And if I had other groups inside there, I'd work my way. So you might have nested groups and you're working inside outwards. So in here, what I want to do first is the exponent. So 3 squared, 3 times 3, that's what that means. So 9 plus 1, and 2 squared, that's 4 plus 1. And then I'm going to add those. So, there's no multiplying or dividing in those. Again, these are still groups here that I'm worried about. So it's going to be times 10 over 5. And then, so I've done my groups. And then that also had exponents. So at this point, I have no exponents. I'm not going to do 6 minus 2. Instead, what I'm going to do is I'm going to try to do any multiplying or dividing. Well, here's some multiplying. So I'm going to multiply this. I'm going to say this is 2 over 1. So I'm going to multiply these two together. And that's going to be 20 over 5. And now I can divide, which is 4. And then I'm going to add or subtract. And so 2. Now I could have done 10 divided by 5 is 2 times 2 is 4, and did it that way. There is some flexibility in this pattern here, but if you follow the order of operations, it will protect you from making mistakes. So a real common type of problem would be some that people kind of have issues with is they have something like 6 times 8 divided by 4 times 2. And the natural instinct is to see this as two groups. There are no groups here. This is just a left to right issue. All you're doing is multiplying or dividing left to right. So what you should do is you should combine these two, get 48, then divide by 4, get 12, and then multiply by 2 and get 24. This is not 48 divided by 8, it's 6. No. This is 6 times 8 divided by 4 times 2. And sometimes you will have a calculator and you'll type it in and you'll get an answer, and you're like, that answer doesn't make sense. That's because the calculator is using the order of operations, and if you didn't put parentheses when you meant to, the calculator doesn't know that. It just follows the order of operations specifically. All right, let's real quick talk about conversions here between different formats. So if you want to go, let's say I want to go fraction to decimal. I have 3 over 8, and I want to turn that into a decimal. The way to do that is I divide. And I've already talked about that. I'm just going to use a calculator here and say 3 divided by 8 equals 0.375. So 3 divided by 8. Just type it in there like a division, and that's how you convert it. Let's say you want to go decimal, and I'm going to say terminating, because like I said, it's a little more confusing doing a repeating decimal, terminating decimal to fraction. So let's say I have 0.68, and I want to turn that into a fraction. Well, this is, in words, 68 hundredths. So you write that as 68 over the place value, tens, hundreds, thousands, 10,000, so on. So over, and then you reduce that down. So 34 over 50, so 17 over 25. So that's how you convert there. If you want to go decimal to percent, I don't know why I put that there. Let me get all the. Oh, nope. Oh, I'm making it worse. Let's just erase it. That does this to be faster. Okay. Let's go decimal to percent. I don't know why I put it in the middle. So 0.031 is 3.1%. So percent means per 100. That's what percent means. Cent is 100. So if I want to think about, turning this into a fraction, but not a full fraction, just over 100. So I go, where's the hundredths place? Well, it's where the 3 is. So this would be 3.1 hundredths, hence 3.1%. Usually what you think about is you just move the decimal 2 spots to the right to turn it into a percent. So likewise, if you want to turn a percent into a decimal, let's say I have 235.68%. There's a decimal in there already. Well, it's not a true decimal though. This is out of 100. So what I'm going to do is, just like here where I move the decimal 2 spots over, to go the other way, I'm going to move it 2 spots the other way. So this is going to be 2.3568 as a true decimal. And then if you want to do percents into decimals, or fractions into percents, and percents into fractions, usually what you do is you do the percent to decimal stuff, and you do the fraction to decimal. So the decimal is kind of like the middle step between going from a fraction to a percent. So like if I had 3/8, I'd probably turn that into a fraction or into a decimal first, and then say, oh, that's 37.5%. And likewise, if I had that as a percent, I would turn it to a decimal, and then I would, 375 over 1,000, which would reduce down to 3/8. So, that's usually how you would do it. Is you do that, you turn it to a decimal, and then you bridge the gap. So that is just a real quick conversion thing. I guess before I move on there, I might want to mention, like, let's say you had 2/3. So I want to write that as a percent. So 2 divided by 3 gives me this 0.0 6 repeating forever. Well, if I want to turn that into a percentage, I want to move it 2 over, so this is 6, and then there's a 6 with repeating, so 66.6 repeating forever. But remember, 0.6 repeating forever is the same as 2/3, so you could write this as 66 and 2/3%. Both of those would be correct. Now, if it asks you to round at a certain place, then, you know, let's say this, it said round to the nearest hundredth of a percent. I notice hundredth of a percent, not nearest hundredth. Hundredth of a percent. So let's say we had 5 over 13. Okay, so I'm going to say, all right, what is that? That's not going to come out pretty. 5 divided by 13 comes out to be this. So 0.386. All right, so I gotta remember that if I don't write it down. 0.384615, I think that's what I had. And, you know, more. So I'm going to turn this into a percent. I'm going to move the decimal 2 spots over. So 38.4615 percent. And then nearest hundredth of a percent. So notice now this is the decimal, this is the tenths, this is the hundredths. That's where I'm going to round my number. And since this is a 1, you know, and if this digit is between 0 and 4, this stays a 6. If this digit is 5 to 9, it goes up. So this is 38.46%, approximately. Again, it's not exactly that because I rounded. All right, so let's talk about the number line. And that's going to lead into the last few things here. So number line is a way of showing how all the real numbers are related. Usually we have 0 at the center, and then you count off by integers. As you get bigger to the right, the larger positive numbers, and as you move farther away from 0 on the left, you get more negative. Oops, that's positive. Okay, -4. Okay, and then, you know, any other, like, you know, you have a half in here. You have, you know, if you were talking about irrational square root of 2's in there somewhere, you know, so every real number somewhere on that number line. But you usually label it with integers, but you don't have to. I mean, if you were doing, let's say, trigonometry, you use pi a lot, so you might have 1 pi, 2 pi, you know, 3 pi, and, you know, count by pies, because pies play a big part in trigonometry. So, you know, it doesn't have to be scaled in integers, but usually we do. So some relationships here. Let's see, greater than here. So the first number is farther to the right than the second. So if I claim -2 is greater than -4, what I'm claiming is -2 is farther to the right on the number line than -4. And that's true. This is a true statement. -2 is greater than -4. And you might think that might, if all you deal with positive numbers, that does not make sense to you. You know, 4 is greater than +2 because 4 is farther to the right than +2. We're not talking about size, we're talking about value. And you think about, like, negatives as being debt. If you owe $2, you actually have more wealth than if you owe $4. The more debt you have, the bigger your debt, the less money you actually have, the less value you have. So if I owe $4, I'm actually worse off than if I owe just $2. And this kind of idea with these negatives trips people up sometimes. So be careful when you're looking at the negatives. The greater one is the one closer to 0 because that's the one farther to the right. Likewise, if you have a less than symbol, the first number is farther to the left. Than the second. Okay, so I could use these same numbers, and -4 is less than -2, or +2 is less than +4, farther to the left. And then the last thing we're going to talk about here as a review, absolute value. And again, it's tied to the number line concept. Absolute value, this is equal to the distance from 0. Sometimes you might hear this referred to as the magnitude. So this is what people a lot of times think about when they look at this first one. I said -2 is greater than -4, and initially they said, what? That doesn't make sense. Is because they were actually thinking absolute value. The absolute value of 2 is 2, because 2 is 2 spaces from 0. The absolute value of -2 is also 2, because it's 2 spaces, just 2 spaces in the other direction. So absolute value is how far away it is. You drop off the sign, and that gives you the absolute value. And once you say absolute value is always positive, because the absolute value of 0 is 0, and 0 is not positive, it's neutral, not positive or negative. And then just keep in mind order of operations and things. If you had something like this, what you would do is you do this absolute value part first, and you would get +2, but then you'd have this negative on the outside. So this negative still out here waiting for you. It's still there. So even though the absolute value of 2 is 2, this is saying the opposite of the absolute value. And so that would be -2. So, is this negative because of the absolute value? No, it's not negative because of the absolute. It's negative in spite of the absolute value. If this had been negative absolute value of -2, the answer would still be -2. Because the absolute value of -2 is +2, and then the opposite of that would be -2. So, you can have negatives, but this doesn't mean the absolute value is negative. It just means this negative changed the answer to a negative. Right, so there's a kind of a quick review of arithmetic, things you need to know starting this course.